Good morning, everybody. So, as we are now in carbon and compounds, in last class I taught you what is carbon and what is the percentage of carbon in earth crust and as well as on the earth. Same way, versatile nature of carbon we study. So, why carbon is always unique? What is the reason behind it? Is because of four properties. So that four properties only we studied in the last class fully. That is what versatile nature of carbon. So if you'll observe here, why carbon is always special. So if you take the total elements till now, 118 elements, will you all accept it or not? The total known elements to the human by today, 118 elements. But out of these all elements, we know that 80% of around 92 elements, of approximately 80% of metallic elements only present, and only 20% are non-metallic, and as well as in that 20% only non-metal plus metalloids also there. So among all these elements, whatever they discovered so far, the number of compounds formed by carbon is very, very high. So carbon compound, the compounds formed by the carbon, every day the number is increasing. That is what a carbon is extremely very, very high. Even the chemist who has been working on chemical laboratories, so even the every month, even today, every day, every month, several compounds will be synthesized, which is with the help of carbon. So that is what every living organisms having large variety of carbon compounds in the different forms, including the body inside what we have amino acids, what we are having fatty acids, what we are having like various vitamins, our carbohydrates, everything. If you take enzymes which are involving in our things, our hormones, all these are compounds of carbon only, or proteins, amino acids, fatty acids, all the things. That is why the compounds discovered by chemists till today is around approximately even 5 millions. But if you take NCRT, they'll say million compounds because there is no count. Like they're saying millions of compounds are formed. So just one statement you remember, all other elements, whatever the maximum possibility of formation of compounds, if you take remaining all 117 elements, if you combine them in different ways, every element having a different combination and different number of compounds it will form. All the number of compounds formed by all other elements is not even equals to the compounds formed by only one and only element. What is that element, everybody? Is carbon. So even though carbon will form only covalent compounds, but due to its smaller size of atoms, so the compounds formed by these very, very stable or unstable in nature? All of you? Stable in nature. So that is what it is having four different properties which is not shown by any other elements. That is what we will say versatile nature of carbon. So the first property which is very, very popular is, as we know, it is, what is that, guys?
Tetravalent
carbon, or we can say tetravalency. So means carbon is having how many bonds? It will be having 4 bonds which can form with so many metals, so many elements. Like you can take oxygen, sulfur, nitrogen, halogens, everything, and it will form strong covalent bonds. So that is why it will be having different elements form compounds with a different specific properties. So with the carbon. Next, the most popular property of carbon, which we already studied, that is only we used to call it as, what we used to call it? Catenation,
Catenation.
called as self-combination. So a carbon itself, it can link with another carbons in a three different forms. That is what we will say. What is that? Either straight chain carbon, or it will be linked with the how guys? A branched chain carbon like this. Many possibilities. It will be keep on linking and will form branched chain, or it will form how guys? It will form, everybody should tell,
Ring.
form the ring-like structures. So everything you have to know that this is the unique property of carbon, which is not shown like this extent by any other element. But the one and only one more element, what is that? Silicon will form with hydrogen up to how much guys? Up to
7 or 8.
8. But after that, the bond formed by silicon is weak, covalent bond. So it will breaks automatically after more 7 or 8 silicon. So that is next. Third property is multiple bonds. That is what we are going to study in our today's class. So multiple bonds, which we already studied in metals and non-metals side are. So carbon can form single bond. Carbon can form double bond. Carbon can form triple bond. Is it yes, everybody? So this is what formation of multiple bonds among itself. It is a specialty of carbon. And last one is isomerism. Means the same chemical formula but different physical structure. Same chemical formula but different appearance or different physical structure. So it's to called as isomerism. So different way we will study what is isomerism and examples of that. So now this is all about it. Now you can see isomerism and all we'll study later. Now if we get back to here, we are going to see now in our today's class. So which is already we are very familiar with that is only covalent bond formation. So as we know, covalent bonds are three types. So all of you keep ending covalent bond formation. Covalent bond formation. So this is all already how you already knows, you are all very familiar. Just for brush up I am teaching. So now, first of all of you tell me, so how many types of covalent bonds we can form? You all people knows.
3 types.
Three types. One
Three.
is everybody single covalent bond. Yes, single covalent bond. So single covalent bonds means, as we know, covalent bond means only by what? Only by donating or receiving or only by sharing?
Sharing.
Only sharing. Covalent bond means how many pair of electrons will share? That is what I want. Single pair. Single covalent bond. Single pair means each atom will donate how many electrons? Each atom will donate with the how many guys?
One pair of
One pair electron. One electron. Understanding? So if I take two atoms, atom 1 and atom 2, so each atom will donate how many electrons, guys? This atom will share
one electron.
share one electron, not donate, sharing. So if I take example, for example, hydrogen. So each hydrogen will share one electron. So that this pair, one pair will represent with a line called as single line. So that is what single bond H, single bond H, single covalent bond. So if we take double covalent bond, so means each atom will share how many electrons?
2.
Electrons.
2 electrons.
2 electrons means totally how many pairs? 2
2
electrons
pairs.
each.
2 pairs.
2 electrons each. So that totally how many pairs? 2 pairs it will be make it. So example it will take. Who is the example? Oxygen.
Oxygen.
So you can take oxygen. So R I can represent like this. So each it is sharing 2 electrons. So oxygen. Next, what is the third one? Triple
Triple
covalent.
bond. Covalent.
Covalent bond. So if you will observe, triple covalent means each one will share so much.
3.
Shares
3 electrons.
TH are 3 electrons. 3 electrons each. If you notice it. So what is the example? Which will know that nitrogen. So nitrogen, if you notice, how many total pairs, guys? How many total pairs? 3 pairs of electrons. So each one will share 3 electrons each. So this is what types of covalent bond formation. They can form either single covalent bond, double covalent bond, or triple covalent bond. Is it okay, everybody? Please respond. So now let us discuss what is mean by covalency so that you can easily will form the compound. So please all of you make a heading of covalency and write the definition. Covalency is a very important definition which is there in our NCERT book also. So write it. The number of electrons contributed by the number of electrons contributed by each atom in the formation of a covalent bond. Covalent bond is only called as what, guys? What we used to call covalency. Understanding? So for example, so in the molecule of N2, you tell me if I have taken in the molecule of nitrogen, molecule of N2, what is the covalency of nitrogen? Anybody?
3.
Covalency of nitrogen, not nitrogen molecule, nitrogen. How much, guys? Anybody? Covalency of nitrogen, all of you. 3. How many is sharing? Each one, how many it is contributing? 3. Do you understand, everybody? Yes, please. Next, if I take O2 molecule, what is the covalency? Each oxygen will donate. If I take hydrogen, each one will donate 1. Covalency. If I take chlorine, Cl2, each one will donate. Sorry, each one will share. Each one will share 1 electron. If I have taken methane, CH4, what is the covalency of carbon? Covalency of carbon. Carbon 4. That is what you have to understand. Do you understand, everybody? Yes, please. Please respond.
Yes,
that is what covalency. So covalency means how many they are sharing during the formation of covalent bond. That is what we used to call as covalency. Hope everybody understand. Every clear, guys? Because this question also sometimes appears in our board exam for 1 mark. What is the covalency of a particular element in a given compound? Do you understand, everyone? So what do you mean by covalency? Covalency means number of electrons sharing during the bond formation. Any doubt, guys? Please respond. Now,
No, sir.
these all molecules we can separate into 2 types. That is what we will say. Based upon if same kind of atoms the covalent bond is forming, we will say like homo. And if the different atoms the covalent bond is forming, hetero. So both the structures they are given in our NCERT also. Your choice, whatever it is, I'll be. So according to that, you can follow. So now first one. So all the compounds or molecules will be make it into 2 categories. One is homoatomic covalent molecules. Homoatomic covalent molecules. Homo. What do you mean by homo? You all people knows. What do you mean by homo? Anyone? Homo means same type of atoms the bond will form, then it is called as homo. So can you tell me any example? A compound, sorry, the compound or bond is formed due to the formation of same type of atom. All of you should remember, same type of atoms. If the bond is formed, then that is called as homoatomic. Okay, everybody, Pawan, understand Pawan? Mukesh, Saigarde? Disturbance is coming, Ishali. Please mute. So if the same type of atoms is happening, the bond, the covalent bond is forming between the same type of atoms, then that is called as homoatomic covalent molecules, or we will say compounds, covalent compounds. Can you give me the examples of this? Anyone, please? No issues, Ishali. Please tell me. Sai Karthik? Mukesh, examples please. Same type of molecules. Can I take nitrogen? Can I take hydrogen molecule? Can I take chlorine molecule? Can I take oxygen? So this all is called as examples of homoatomic covalent compounds. So let us draw the structure. So formation of hydrogen molecule, for example, book is also it will be given. So it has to be done very clearly. So formation of hydrogen molecule, let me take all of you. So how it will be coming hydrogen molecule, tell me. So as we know, hydrogen is a diatomic or monatomic molecule. They all are
Diatomic.
most of the gases, they cannot survive individual atoms. They will be always combined together. So that is what diatomic molecule. So you remember one more thing I want to say. Whenever you are representing the formation of any kind of substance, we will represent only in the valency cell. Do you understand, everybody? What I am saying? Only will represent what cell? Will represent only the valency cell. Simply follow, when we are representing the formation of any compounds in the chapter, only will represent the valency cell alone. So that is what you please need to remember. Will depicts using that either dots or cross also, it is your choice, but you have to remember that only it will be represented by two things. One is either the number of electrons in the valency cell. You can represent either with a cross or dot, your choice. CBSE is also saying the same thing, but only valency cell you should show. Do you understand, everybody, what I'm saying? Clear, all of you? So now if you take hydrogen, tell me hydrogen, what is the valency cell? Only one cell it will be there. So one cell, and that is a symbol of hydrogen, having how many electrons? Having how many electrons? One electron. Represent like now, plus one more hydrogen having how many electrons? Having also one electron. So they will both chemically combine together and they will form what molecule they will form, guys? They will form hydrogen molecule. So they both will combine and they will share each other. That is what we will say. How many shared pair of electrons? Shared pair of electrons.
One shared pair.
That is what. So shared pair of electrons is one pair. So now, sir, you may represented here with a cross, here with the dots. Why, sir? So your choice. I will show you that also. You might be think, sir, my teacher won't give if I'll keep dots, sir. Is it right or wrong, sir? Both are correct only. So your choice. This is what formation of hydrogen. I already taught you. Do you remember, guys? All of you? Please. Now, next formation of oxygen. Already in metals and non-metals chapter, I taught you very in detail this. Formation of oxygen, O2 molecule. Let me say, who will say? Tell me. Remember always, when we are drawing the formation of molecules, only valency cell will draw and number of valence electrons also you should represent. Do you understand, everybody? Maitrayan, Kevin, that is what you have to remember it. And one pair of electron, one line indicating. Now oxygen, tell me. So oxygen, if I take one atom of oxygen, having how many electrons?
6.
How many electrons? 6
Six,
electrons. So I should represent 6. 1, 2, 4, and as well as 6. Next, one more oxygen atom. It will be combined with the one more oxygen atom. That is what full complete valence electrons you must represent. Have you all noticed it how I am representing? Please respond. That is what it is. Now, each oxygen will share how many electrons, guys? Each oxygen will share how many electrons?
2 electrons.
2 electrons, and remaining 4 electrons, where it will be there? Remaining 4 electrons, it will be above. Understanding? That is what unpaired electrons must be shown if they are having in the valency cell. Hope everybody clear? Unshared electrons must be represented above the atom without fail. Now, shared pair of electrons is totally how many shared, guys? How many pairs?
2 pair.
That is what we have to represent like this. So 2 pairs of electrons, it is sharing. Are you clear, everybody? So how many pairs here? 2 shared pair of electrons. Pair of electrons. So that is what you have to remember. Like that. If you take nitrogen we can draw or not? Fastly. You should draw along with me. Nitrogen you take. So nitrogen, how many valence electrons? Fastly. What is atomic number? Nitrogen is 7.
7.
So atomic number is 7.
2,5.
Electronic configuration is 2,5. So how many?
5.
5 will come. You can represent anywhere. So I am representing, as it is sharing 3. 3 only one side I am representing. Now you can take one more nitrogen. So again the same thing. So 2 and 3. So this side I am representing 3 because sharing. So that is also very careful. So of course anywhere you can represent, nothing is there. So but our convenience is always important. So if I draw now nitrogen, so 2 electrons is unpaired and another how many electrons are sharing? 3 electrons each, so that it will form triple bond. So how many shared pair of electrons? All of you? 3
shared
shared pair of electrons. Understand, Sai? Shared pair of electrons. That is what it is. So here you see, guys, I represented with the dots. Before I represented with the cross. Now I am representing with the dot. Which is right, sir? Which is right? Yes, please. All of you. Both are right.
Both are right.
Your choice. Now, whatever you are familiar, you can draw. Sir, will you prove it? Is there any problem will come? No problem will come. As it we can even fight with anybody. So the thing is, you can see here, all of you, read this everyone, what they are saying. Electronic configuration of nearest noble gas, helium, which has 2 electrons in its cation. And I hope you are all very, very familiar to find the nearest electronic configuration. Is it yes, guys? Stable electronic configuration. Can I believe?
Yes, sir.
Yes. So I hope everybody can do that. Let me see that. Now, all of you read here. We can depict this using dots or cross to represent the valence electrons. Are you clear now? Any confusion? So no doubt should be there. You can represent with either dots or cross according to your convenient. So whatever you can follow. So now book is given cross. So you also can follow cross. You don't like cross, you can follow dots also. So they're mentioning clearly, so you don't need to bother about anything. So this is what about it. So these kind of compounds, molecules which is forming, we used to call it as homoatomic molecules. Now, let us take another different atoms if it is forming, then that is called as, please remember, formation of heteroatomic covalent compounds. Hetero, you all people know chemistry will study homogeneous molecules and heterogeneous molecules. Do you remember that? Yes, please. So that is what it is now. Formation of hetero. So hetero means same atoms or different atoms?
Different.
Different.
Different atom. That is what it is. Now, book they are not drawn the structures, but they mentioned us to draw. You might be noticed that I will show you also. So we'll draw, we'll be make it at least one or two compounds so that it will be fine. So let us take the most popular one, which is example. So here you remember, which is formed by how guys? Different atoms or same atoms? First you should remember that. Different atoms.
Different.
Different types of atoms, but you can remember all are metals and non-metals or only non-metals, only non-metallic atoms.
Three non-metals.
That is what only covalent compounds. The first example, formation of water. Formation of water. So what is the formula of water, all of you? H2O. Okay. So let us take molecule H2O. So we all people knows first hydrogen, electronic configuration of hydrogen, how much it is? Only cation, 1. Oxygen, how much it is? Atomic number is 1, atomic number is 8. What is the oxygen? K and L, 2 comma 6.
6.
Only you should take valence cell. That is the main thing you have to remember. So you remember what to form one molecule of water. How many hydrogens is needed? All of you? How many
2
hydrogens?
hydrogens.
Huh?
2.
2
2
hydrogens and 1 oxygen. And the size variation also should show. Who is bigger? Oxygen is bigger or hydrogen is bigger? Oxygen. So that is also.
Oxygen.
So I'm taking two hydrogens, you can see. And how many oxygens I'm taking? 1 oxygen. So oxygen, what is the valence electrons? Valence electrons, 6 electrons. So that is you have to remember now. Sir, as it is heterogeneous, can I represent one is with the cross and one is with the dot? Of course, you can represent. That is also your convenient. So your choice. So I will make it. So whatever you like, you can follow. So now this is the oxygen, which will react with the 2 hydrogens like this. So I will represent with this is hydrogen, 1 electron sharing, and here also hydrogen, 1 electron is sharing. So middle oxygen, how much is remaining? 2 electrons is gone. How many electrons is remaining? Sharing, unpaired, unshared electrons.
4.
4. Okay.
4.
What I am representing. So your choice. So this is what a water molecule. So how many covalent bonds are there? Single covalent bonds. Understanding? So single covalent bond. So I can represent like this. Oxygen H and H. Is it right or wrong? Yes, please.
Yes, sir.
Yes, sir.
So that is what you have to remember it. Now, according to the book, you can remember the electrons shared by one atom will take it as a cross, and another atom we will take it as a dot. So that is what basically will follow. So in book also they will follow the same thing. Now your choice, you will be comfortable with all cross only. You can follow the cross. You'll be comfortable with all our dots also. You can follow that. But if you want the electron shared by one atom, you can take it as a cross, and another atom you must take it as a what? You must take it as a dot. So your choice. So what is convenient for you, but believe only one thing and you follow, so that no confusion should occur anywhere. Now, for example, methane structure. If we take next, we are going to draw methane only. So draw methane structure, all of you. Methane. What is the methane formula? Formation of methane. Write it. Formation of methane. What is the formula of methane? All of you.
CH4.
CH4. Okay. So now, sir, I want to represent the electrons shared by carbon is cross, hydrogen is dot. So your choice. So because book is also they'll represent line. So let us take now. How many hydrogens is needed for formation of
Four
carbon?
hydrogens.
Everybody.
4 hydrogens.
4 hydrogens.
Hydrogens. Understanding? 4 hydrogens needed with what? One
1 carbon.
carbon. So to make you represent, I will represent like this. 4 hydrogens. Is it okay, guys? Any doubt? Clear? Everybody? With 1 carbon. 1 carbon. So carbon having how many valency? What is a carbon? Atomic number. Atomic number is
4.
6, 2, 4. So
4.
2, 4. So how many it will be there? How many?
4.
4.
I will represent like this. Is there any problem for anybody? Please let me know. Are you clear? Yes? All of you? So now they will combine and they will form a molecule. How clearly I am drawing, you observe. So middle who will be there? Middle who will be there?
Carbon.
And it is reacting with the 4 hydrogens. So you can draw 4 different positions, 4 hydrogens. Now, everywhere hydrogen will come. First, fill the data. How I am drawing the structure, you have to be. Now, as we consider carbon, how? Cross or dot? Cross or dot?
Cross.
Cross. Everywhere make cross. Everywhere make cross. And hydrogen, how we consider? Dot. So you can represent dot. But if it comes to the bond, still it will form one dot and one cross, one pair of electron and hydrogen, single bond hydrogen. Am clear? Any doubt?
Yes, sir.
Brothers, now, sir, is it possible to write? Is it correct? Yes, I will show you. Clarity should be maintained between you and our books. Have you seen the structure of methane now? All of you here, they never given hydrogen and they never given carbon separately. But have you seen the structure of electron dot structure of methane? Are you clear, everyone? Yes or no?
Yes, sir.
That is. So,
Yes, sir.
this is what your choice. So, whatever it is convenient, you can follow. None of you will say anything. Now, let us draw last molecule within this 2 minutes of time. That is what? Ammonia. So, draw fastly, everybody. Ammonia. So, ammonia, you can say, what is the formula? Formation of ammonia. Formation of ammonia. All of you. Formation of ammonia. Yes. So how many nitrogen molecules? NH3 it is. How many nitrogen molecules? One
nitrogen.
Okay. So one nitrogen molecule. So how many having valence cell? How many? 5. Understanding? With how many hydrogens? 3 hydrogens. Say, you might be asking me, when I am drawing the nitrogen molecule, I represented the valence electrons like this. Now I am representing like this. Have you seen? Based upon our convenient, we can take. Now there, one nitrogen with another nitrogen. But here, nitrogen with how many hydrogens? 3 hydrogens. That is why different positions I am keeping. Do you all understand, everybody? Clear?
Yes, sir.
That is what. Let me take this hydrogen is cross. I am taking hydrogen is cross now. So my choice. So totally nitrogen will come. How many lone pair of electrons? Means unpaired, unshared electrons. 2 and one pair of unshared electrons. And you can see remaining. I will write 3 electrons is sharing with the hydrogen. So hydrogen now I am representing with a cross or dot?
Cross.
Cross. So before carbon I represented a cross, hydrogen dot. Now hydrogen dot, nitrogen cross dot and hydrogen cross. Your choice. So what is the structure will come? Nitrogen. See, lone pair of electrons, unshared pair of electrons, compulsory you should represent if the valency cell has. So that is what the format. So all of you should follow very strictly. If I am not representing here nitrogen, this two, it is wrong structure. Are you clear, everybody? Please. If these
Yes, sir.
are not represented, that structure is not correct. So that is all of you should follow it and make it. Till here complete it. Please everybody get back to the meeting. Then we'll study the general properties of covalent compound. Very, very important. Okay, complete it till here. Any doubt?
No, sir.
Okay.